First off, I just want to thank everybody for joining us today for Dr. Retsef Levy's talk here at the Morrison School of Agribusiness. I actually stumbled upon some of Dr. Levy's work just on SSRN. So and I figured why not reach out and invite him to participate in our seminar series this year, given that we're completely virtual. So I emailed him, he said yes, and here we are on March 31st. So for those of you who don't know Dr. Levy, Retsef is a professor of operations management at MIT Sloan School of Management, and he has a number of other appointments. He does a lot of work on decision-making under uncertainty, and specifically looking at complex systems like healthcare, and more recently, looking at food and agricultural supply chains, which is what he'll be presenting on today. And I will let him kind of take it from here, but thank you for joining us, Retsef, and go ahead.
Yeah, thank you, Lauren. Thank you, everybody. I'm going to present, but feel free to stop me if there is any question in the middle. I want to make it interactive. And Lauren, if I'm not sure I'm going to see all the hands, so if you identify someone that wants to ask the question, just interrupt me, or just everybody. I don't think we have too many people on the line, so just feel free to jump in and ask a question without even raising your hand. So
great. And if somebody,
I'm perfectly fine with this. So
and if someone wants to,
I'm from Israel. I'm used to be. I'm from Israel. I have 6 kids. I'm used to be disrupted all the time. So
excellent.
Okay.
I'll monitor the chat box too, just in case.
Yeah. So what I would try to do today is to share some of the work we've been doing in the context of how food and agriculture supply chains can pose human health risks. And this is just part of a broader body of work that myself and many others at MIT and MIT Sloan in particular are doing in various domains related to food and agriculture supply chains. And hopefully at the end, I will try to give some sense about the totality of, or the broader scope of what we are doing and what we hope to accomplish. This is something that is already happening for the last over 7 years now. So it's already going on for a while, and we believe that that's a strategic direction for the next 10 to 20 years. So we intend to invest more efforts in that. So let me just start by motivating the work, and again, I would like to basically make the point that the food supply chains and agriculture supply chains have a major impact on human health. And there are at least 4 important aspects that are worth to be highlighted, but probably not necessarily encompass all the impact of food supply chains on human health. But maybe the very basic one is the fact that food is one of the essential needs for human well-being and health. And in that context, the issue of food security is a major issue, a major global issue. Today, even today, there are about 700 million people worldwide that live in hunger. And if you broaden the definition of food security to access to fresh vegetables and fruit, or healthy food, more generally speaking, then this is by no means a problem of only developing countries. Particularly in the US, you have the notion of food deserts that I know that a few of you at least worked on this very topic. That basically are millions of Americans that live in neighborhoods that are poor, but also don't have any physical access to fresh vegetables and fruits and other healthy food. And these challenges of access to healthy food, or access to food more generally, stand in marked contrast to the fact that food and agriculture supply chains are characterized by a tremendous amount of waste. Some would say that maybe more than 70% of the food produced is currently not being consumed throughout all the stages of the supply chain. So that's kind of one aspect. The other aspect is the aspect of food safety and adulteration, being still one of the most significant causes of illness and death in the world. We are talking about estimated numbers of 600 million illnesses and north of 400,000 fatalities every year, and many of which are actually young children. And it's perhaps maybe the primary reason of illness among children, contaminated food and water. So that's another major issue. Clearly, beyond the health implication, has major economic aspects and implications. The interaction between food supply chains and the environment is very complex. It's fair to say that it's a two-sided interaction. On one hand, food and agriculture supply chain have a major environmental footprint. For example, more than 25% of the greenhouse emission is coming from agriculture supply chains, and at the same time, the environment has major impact on food supply chains and agriculture supply chains, both on productivity as well as food security and so forth. And finally, maybe very relevant to the recent times and the last year, like COVID-19, but not only COVID-19, many global pandemics over the last several decades, like SARS, like avian and swine flu, are pandemics that fall under the category of zoonotic diseases, which are viruses that evolve in animals, in agriculture supply chains, and jump to humans. And I guess that not too many words are needed to tell you what could be the risks of that these days. And I'm not going to talk today about all of these topics. I'm going to primarily focus on the issue of food safety and adulteration and the issue of zoonotic diseases. And the common theme would be around the potential of supply chain analytics and multidisciplinary field research to create both methodologies, frameworks, but also concrete tools to inform global and local policy. And I'm going to talk about research that is relevant to the US, but also research that is more global, and talk about projects that we have ongoing in China. Okay, and again, feel free to stop me if there are questions. Okay, so let me start with the issue of food safety and food adulteration. And it's fair to say that from the public perspective, most of the exposure to this topic comes through visible public scandals that emerge from time to time. And on the right-hand side here, you see some quotes from, I don't know if everybody remembers, but several years ago, we had a series of incidents in Chipotle, the restaurant chain, around different outbreaks of foodborne illnesses that exposed major issues with their processes and their food safety practices. In fact, very recently, there was a fine, the largest fine ever imposed on a food company. I think it's north of $125 million that they were because of these events that they were fined. Chipotle was fined. On the left-hand side, you see news media articles on the melamine incidents in China. This is 2008. This is perhaps the most significant or well-known incident in China, where farmers and brokers in the dairy supply chain added to the milk a poison called melamine with the attempt to increase the perceived protein level with respect to the tests that existed at that time. And increase the price that they could get for the milk. And that contaminated milk ended up in baby formula and basically caused serious adverse effects, including fatalities in tens of thousands of babies and children in China. And fair to say that that was a turning point in how China has addressed, and including the government in China and the public in China, how the issue of issues related to food safety, and food safety is a general important area. That was a tipping point. Since then, the Chinese government and the public in China is very much focused on these type of issues. But beyond the public perspective, I would like to highlight what I would call the regulatory perspective. And there, the name of the game is the scale. Just to quote two facts that sort of will bring that point home. If you think about this, the US FDA, the US FDA has currently to handle more than 40 million unique food line shipments imported into the US every year. For each one of them, it has to make a decision where it's safe to bring it to the US, with the ability of inspecting or sampling, if I use the professional terminology, about 1% of these shipments. So you can imagine that with such a scarce resource compared to the volume that you need to manage, it creates major challenges. And China is another place where food safety incidents is a gigantic. It's a gigantic country. The number of food incidents, just reported incidents, is at the thousands or hundreds of thousands. And these are just the reported incidents. So scale is a big issue, and this is why it's so important to be able to use data and understand risk in a much more refined way, in a way that can actually inform how regulatory resources are allocated. And that's going to be a theme that I will try to get back to throughout the talk today.
Retsef, I have a quick question. Just more contextual. Comparing United States standards with other countries, who's the most stringent when it comes to food safety standards, containing foodborne outbreaks, those sorts of things?
So I don't think you can make blanket statements here. So let me just share a few thoughts. So clearly, Europe and the US are relatively similar, but there are differences, and sometimes the Europeans are more stringent than the US and vice versa. Actually, if you look on the regulatory, the words of the regulatory rules in China, just take China as a developing country, it's not that different than the US, and actually in some places China is actually more stringent than the US, and most of the time it's the opposite way. But the rules are not, it's the starting point. What matters more is the mechanism of enforcement, and because you can have rules, but if you don't have good mechanisms to enforce the rules, then it's not really helpful. And I think that almost all countries, including the US, struggle with enforcing the rules, particularly because enforcing the rules is not just a local or national challenge; it's actually a global challenge. Because, for example, take the US. More than 15% of the food that we consume in the US is imported, and in some product categories like, let's say, shrimp or seafood, 90% is imported. So if you want to enforce your regulatory paradigm on that particular stream of food, it's not enough just to do it in the US. You need to sort of think about how you actually impose that globally. So this is a pretty complex set of challenges around that. And I'm going to get back to some of this in just a bit. Does this sort of address your question?
Absolutely, yeah. And just the kind of the value of the economic that's lost, like the dollars in terms of what we import and export, just because these standards, how do you enforce them and those sorts of things. So
yeah, so I mean, there are many aspects to that, and once you have a scandal like that, suddenly you have a public faith is lost, and there are, like, just even internally, think about the lettuce green leaf contamination that we had, I think like a year ago, which was again not the first one. I mean, that could kill an industry, right? Like, it's not only that the FDA kind of recalled every lettuce and every green leaf in the market. Probably there were precautions after that the public consumption of these products went down. And if you think about the economic loss to the farmers, it's pretty gigantic, right? So
right, for especially
so absolutely
differentiated products. Yeah.
Okay, so a few more, a little bit more terminology. It's sort of interesting to think about the spectrum of food adulteration, and there are various ways to how to partition that space. But one way to think about it is through the intention perspective, where basically on one extreme there is what we call unintentional adulteration. So maybe the primary example here is what we had in the Chipotle example, foodborne illnesses. that typically are not created intentionally, but could be the result of gross negligence or bad practices or and things like that, right? On the other extreme, there is intentional adulteration that is motivated by terror, like an attack on the food system or other critical systems, like contaminating the water, contaminating food, and so forth, and that also happens. And then maybe in the middle, and that's where the melamine incident fits, is what we call intentional adulteration that is economically motivated, where basically the intention aspect exists, but the motives are not terror, but rather than the expectation for economic and financial gains, like we had in the melamine case. And that's kind of a very interesting domain of incidents. And again, the boundaries are not like clear cut, but what is interesting about economically motivated adulteration, that in order to really understand them, you need to integrate an understanding of many different aspects, including the supply chain structure, the commercial dynamics, the current regulatory environment, and so forth, in order to understand why and when they are more likely to happen. Okay, so I mentioned data, and I want to say a few words about data. I think that one of the challenges in food supply chains and agriculture supply chains is that data is not only scarce, it's actually very siloed and distributed, and usually does not reside in one place. It's very messy as well. It's dirty. It's not unified. So even when data is sort of available, it's actually quite challenging to bring it together. And in fact, many of the examples I'm going to talk about today will be about how to use advanced analytics to actually create data sets that are usable, if I would say. But what I wanted to give you is just a flavor of what kind of data sources we're going to rely on throughout the different examples that I'm going to talk about in more details. And so what you see here is a schematic supply chain route of imported food into the US that started in a farm. This could be a farm in China, a farm in India, a farm somewhere, goes through potentially a manufacturer that then hand it over to a shipper, then it goes through some foreign port, to a US port, to a consignee that brings it into the country, and then from there it goes to retailers or consumers, right? And in the work that I'm going to talk about, we use multiple data sources. Some of them are public and some of them are private. So for example, one public data source is what we call ImportGenius, which is a database. It's not the only database. It's one of the publicly open database of what is called bill of ladings, which are documents that accompany any shipment, any import shipment, that specify parts of the supply chain that are marked here. So basically a document like that will specify the shipper, the foreign port, the US port, and sometimes the consignee, right? We also worked in one of the projects I'm going to talk about was work under a contract with the FDA, and that surprisingly, the FDA has data that doesn't include all the things that in ImportGenius, but also includes things that are not in the ImportGenius, like manufacturer address and place of receipt. And basically, one of the challenges that we had to face, and the FDA cannot do that currently independently, is to how to integrate these two databases. It's actually a non-trivial task, okay? And then in China, as I will show you, we are able to get to the level of really mapping supply chains up to the farm level. And in addition to mapping the supply chains, we also use some regulatory information about test results, historical test results, to try and understand how supply chain behaves and where the problems in the supply chains are. So that's kind of, again, it's a high level, and we're going to get to some, in a minute, we're going to get to some more concrete examples about the different examples. Maybe that's a good place to open for question. Any questions? I don't. Lauren, let me know if I'm missing hands here. Are we good to go?
I think so far, no questions.
Okay. Sure.
Yes.
So. Yeah, so the first project I'm going to talk about, and again, this is joint work with multiple colleagues at MIT, that was done under a contract with the US FDA, and just as a matter of obligation to the FDA, I need to quote that what I'm going to talk about is my own opinion, and our own opinion does not represent the FDA's policy. But before I dive into the details of what we've done, I just want to give context here to those of you that maybe are not aware of that. But as I said, the U.S. has been challenged with the challenges related to regulating the food space. The FDA is also responsible for regulating the pharmaceutical space, and there the paradigm is much simpler in the sense that you have a very clear recipe of what you need to adhere to when you produce a drug, right? And if you deviate from the recipe, it doesn't matter whether it's risky or not. You just are declined from the market. So most of the paradigm in pharmaceutical supply chains is about testing final products and matching them towards the recipe, right? That doesn't exist really in the food space, because think about how many recipes you know for food supply for chicken soup, right? That's like there's no notion of recipe. So things are much more complicated. And in an attempt to change things, in 2011, there was a federal act that is called the Food Safety Modernization Act that was enacted in 2011. And it basically tries to parallel the responsibilities of the FDA in the food space with the pharmaceutical space. And also imposes much greater responsibility on the industry. So, and that's actually very important. So, for example, if you're a pharmaceutical manufacturer and you have a problem in your supply chain, you're responsible. Up to the FSMA law, if you were an importer of food and you brought something from China and there was some adulteration on the food or some contamination, you could say, hey, what do you want from me? I just bought it from the Chinese manufacturer. It's not my problem. Under the FSMA law, you will not be able to argue that anymore. So you will have to actually show that you made sufficient effort to verify the integrity of your supply chain. If it does sound vague, it is vague. So it actually took 6 years before the FDA started to operationalize this law, and even now it's very much work in progress. But what it does say that there is a growing understanding that understanding and verifying the integrity of the underlying supply chains is a key aspect in regulating food supply chains and food products. And at the same time, this is still some fair to say Achilles heel of the entire system here, because most of these supply chains are quite opaque and non-transparent to both the regulatory organizations as well as many of the industry stakeholders. So that hopefully motivates some of the work I'm going to talk about. So what was this work? So the idea was to use available data to inform some of the regulatory activities of the FDA. Broadly speaking, the FDA has multiple regulatory activities, but the two primary ones are import shipment sampling, where these are imports that come to the borders and being sampled, and there's a decision whether they go in and out or being stopped at the border. And then another activities is what is called site inspections, where the FDA is going to sites of traditionally mostly processors, manufacturers, and test them. And the site inspections can be both in the US and actually there's also foreign site inspections. One of the things that came out of the FSMA law was that since now companies are responsible to verify their supply chain, the integrity of the supply chain, you need to build programs to inspect importers and consignees that did not exist before, and develop a risk approach to how to do that. And the only program that really existed before FSMA that had that aspect was actually the seafood program that did include importers and consignees. So the idea here was to take that program and see if we can show how analytics can be used to inform these type of decisions, and also hopefully develop a concept that can then be leveraged and to be used in other product categories, right? So we focused on the seafood here, but again, the concept here is not just to show how to improve seafood regulatory work, but also develop a concept of the potential of analytics to actually inform these type of programs more broadly on more product categories. So what is the data available? So there is past regulatory history of both shipments that were handled by this consignee and site inspections that potentially happened in that consignee, right? We know some basic data about what is the volume of shipments that the consignee is using. And then, the first two things are kind of standard things that the FDA used. Here are the next two bullets are things that actually were not used in the decision, and we wanted to see their potential, which is basically use data from both private data of the FDA and publicly available data about the underlying supply chains that these consignees are using, right? And I'm going to make that in a second a little bit more precise. And basically, maybe other data sets, data publicly available data, where the goal was to try and inform risk related to seafood consignees. So we had about 2,000 consignees in the pool, and we had these consignees dealt over the years with over 1 million shipments. We had to kind of narrow it down because some of the data was missing. So we actually dealt with close to 1 million shipments. And basically what we wanted to inform is that every year the FDA has to decide which are the handful of consignees that will be inspected on site. So this is a very scarce resource to do that. So the question is, can you develop a risk-based approach to inform which consignees should be tested? Where basically, as I said, the current day available data that is being used in a relatively gross way is the one that is marked here. And it's basically, the current approach is let's just inspect mostly the large players, because this way we're going to cover a large fraction of the inflow into the market, right? So that's kind of the current approach. What we wanted to see if we can actually improve upon that, right? So even just trying to do that, I just want to highlight a few challenges, right? The first basic challenge is a data challenge, right? A data quality challenge, right? For example, how do you actually know even what is the entity of consignee? That sounds obvious, but the problem is that actually when you look on the different records, there is no one way to actually represent the consignee. It's a very unstructured data. It's a very dirty data. So just like even being able to say, hey, that record belongs to this particular consignee actually takes quite a lot of work, right? And we had to do this work. But then there's a bigger question. Okay, what do you think that makes a consignee risky? In the sense that, and what risky here is the likelihood of failing an inspection. And every inspection has three possible outcomes: pass, didn't pass, but maybe like you need to change a few things. We recommend that you change things, and then didn't pass and you have to change something. You are mandated to change things, right? What we wanted to see is, okay, can we use data to actually inform this type of work? And in order to do that, we posed multiple hypotheses, and then we translated these hypotheses to actually features that went into a predictive model that turned out to be useful. In a second, I will show you why. But I actually think it's more interesting to talk about what were the hypothesized risk drivers. So essentially, what do we think can make one consignee more risky than another in the context of the chances of failing a site inspection, which is a proxy of not having the right food safety processes, right? So one hypothesis was that companies that are involved in food adulteration share some common supply chain behaviors and dynamics that are different than the ones that do not, right? And if you believe that, then basically you might want to now create a lot of supply chain features, right, in your model. So for example, how many times you are using shipments that go through multiple countries? How many times, how many manufacturers you work with, how many ports you're using, and so forth, right? And these are all hypotheses that then you want the data to tell you potentially which one of them are actually telling, right? Another interesting set of hypotheses had to do with what we call product diversity. So the notion here is that food safety is also the outcome of expertise. So probably if you're a consignee that deals with shrimp and fish and salmon, you probably have more chances to have expertise where if you deal with seafood and pianos. Why? Because in the latter case, you're more likely, you seem like you're actually doing stuff in an arbitrary way, and you maybe not developing expertise in seafood, right? A third set of hypotheses was that often companies that do shady things, they use extensively shell companies, right? So if you're able to use data, for example, the way we did it is to look on the website activity. So how connected the website is to other websites. Does it look legitimate, or even they have website as a proxy, or whether this is a shell company or not, right? And so forth and so forth. So I'm not going to talk about all of the features here, but I do want to take the middle one and show you basically how we actually modeled it from data. And the immediate question, so just remind you what we are talking about. We are talking about a notion of what is an unusual product portfolio for a consignee, right? That will make us suspicious that they don't have the expertise. Now, if you think about that, it's actually not obvious to define what is normal here, right? Like, how would you define what is normal and what is abnormal? So it's not a priori obvious, right? So the way we were thinking about that is in the following way. So we created the following graph. You see here a part of the graph that corresponds to the product, the top most selling product categories. So what is the idea here? We took all the consignees that brought shrimp or seafood into the US, and we looked on all the other products that they handled, right? And each one of those products had the node here in the graph, okay? So here you see the top 25 most highest volume products that they handled, right? And then each one of the products had an edge connecting it, and the weight of the edge corresponded to the number of consignees that handled these two products together, that were bringing these two products. If you look at their portfolio of what they handled, these two products were included. Like, so what is the intuition? The intuition is, hey, two nodes that have a heavyweight edge is a sign that many consignees are actually dealing with that, right? With these two products, and vice versa. If it has a no edge or a lightweight edge, it means that very few consignees are doing that. So that's already giving you some sense of what normal is with respect to the baseline behavior of the population of consignees, right?
Just a quick question. So consignees are going to be sort of like akin to like a manufacturer with different product lines?
No, consignees are like importers. Think about it as importers. Like that's another name for importers. So sorry if I didn't make it clear. So
they're importing.
They are importing, let's say, multiple things, right? Like, right? And basically, if I see that two products, many consignees are importing these two things together, I'm saying, okay, that's acceptable, right? Like many consignees are doing it. But if only two are doing it, I say, hey, well, 2 out of 2,000, maybe that's actually unusual, right? Like, or if you are the only one that are doing it, is what?
Like octopus and cheese is just one.
Yes. So that's probably not very common, right?
Not very common.
Okay.
Or furniture.
Yeah. So yes. So that you got it right. Now, how do I translate that to a consignee? So this is the graph that corresponds to the population of consignees, right? Now let's just think about a consignee. So I'm going to look on the red consignee. That these are the products that this consignee handled, right? And I'm going to use a concept from graph theory that, without getting into the detail, look on the ratio between the edges in between the red nodes to the edges between the red nodes to the rest of the graph. And to some extent, compare how likely is it to handle these products together versus how is it likely to handle them with other products that are not in the portfolio. And essentially, low modularity will correspond to unusual product mix versus high modularity will correspond to a more common product mix, right? So we are using the structure of the graph and the data that we have on the consignee to score the consignee on how the mix of products that consignee is handling is common or less common. Okay, now there's some level of arbitrariness here, but at least there is a data-driven approach to model that. That's kind of a modeling decision that we made, right? So again, that all went into a model, right? So again, the gray here are data that was used historically, and the green were the things that we added to the model, that these were new features that we modeled. And again, when you actually have to predict here, you basically need to predict two things, right? You need to predict what the FDA will test, will inspect, or we try to predict what were the decision of the FDA. And then given that decision, what will be the outcome of those inspections. And basically we use the multiple models here. Again, I don't think that the details, the technical details are very important, but what I want to actually highlight is a fundamental technical issue, which is what we call an unobserved sample selection bias. So if you actually think about that, my data looks like that. If I look on the population of all the consignees, some of them were inspected by the FDA, for which I have data if they failed or not, but many of them were not ever inspected. And actually, it's not generated by some uniform sampling of the population, because it's being informed by the current policy of the FDA. So you have to ask yourself a question, whether the way the FDA currently is generating this data is not creating a bias in your model. And for example, the Heckman model is a statistical model that tries to capture bias, selection bias. And when we actually applied it, we actually saw that there is no selection bias, because, and it actually makes sense because we actually currently control for all the features that the FDA is using to actually make these selection choices, right? So again, that kind of gives you optimism that we don't have bias here in the model, and we can rely on the model, including the outcome predictions of the model, also to consignees that were never inspected by the FDA, and not only by for the ones that were inspected. And when we test the performance of our algorithm, so AUC is a metric to actually evaluate the value of a classification model, the quality of a classification model, where half is basically random guess and one is a perfect algorithm. So the two things here, we can actually predict very well how the FDA will select. And that's actually by itself a problem, right? Because it's not very desirable to have a very predictable choice of who will be tested, right? Like if you have a very predictable choice, that's actually telling everybody that they know in advance if they're going to be tested or not. That's actually not good, right? We actually can even predict the outcome quite well. And when you actually look on what the FDA is doing, this is the green. This is actually pretty kind of remarkable. The FDA seems to currently predict against risk. Like it's almost like and it's actually not surprising when you understand what they are doing. They're testing the big guys. The big guys are actually more likely to be safer because that's kind of their expertise, right? And even we just use their own data currently in a more rigorous way. That's kind of the blue that gives you some better performance. And then the red is what we actually with our additional data. So you can see that you actually get a better signal of risk here. And 0.68 65 is not an amazing algorithm. It's at best mediocre, right? But let me show you what is the value of this, and then I will answer your question, Joachim. Okay, so I'm getting back to you. So let's just see what the value of this. Oops, well, I'm going backward. What's going on? Okay, what we were able to show is, as I said, the FDA. These are the scores of the risk scores that our model generates for the non-inspected companies, and the blue is for the inspected company. As you can see, the inspected companies seem to be less risky than the non-inspected companies. And when you actually use our model, and we did some robustness there to optimize, basically given the same number of inspections, and you optimize to actually go by risk, if you believe our model, you can actually improve the detection rate of problems by more than 60%. So even the point is that when you have scarce resources, even when you have a little bit of risk signal in the data, it can actually have a major impact about the efficiency of your regulatory work. Yes, there was a question. Go ahead. Is that Joaquim or Joaquim?
Yes, thank you. So
Yes.
my question is, what is the exclusion restriction of the Heckman sample selection model in this case?
You mean what are the variables that are included in each one of the equations? That's the question.
Yes, exactly.
Yeah, so I don't remember all the details. I'm happy to send you the paper and you can take a look. But we basically we're basically using the various features that you see here, right? And then we do robustness when we actually look only on the things that presumably the FDA is using. And in all cases, basically the correlation between outcomes and the selections they seem to be zero. So the correlation factor that the Heckman model is giving you, the bias seems to be zero. So there is no correlation. Given the features that we control for, there seem no sample selection bias in our model. I think that what you're asking about is that there are, I mean, there's no science, there's not exact science around Heckman, but there are, traditionally you want to have the variables in the selection equation different than the variables of the outcome equation. But frankly speaking, when you actually read the literature, that's not necessarily true. You can actually do also residual analysis. We do quite a lot of robustness checks in the paper, and I'm happy. I mean, it's actually available on archive. I'm happy to send you the link so you can sort of look on all the robustness checks that we did there. But beyond just the statistical analysis, we actually, since we work with the FDA, we know exactly what they are using. And it seems that the model currently controls for most of the features that they are using when they actually make those decisions. Okay, hopefully that answers at least at the high level without getting into the details of the specific equations.
Yes, great, thank you.
Okay. So just to make the point before I actually switch gears, because I see that I'm a little bit slower than usual, but the FDA launched recently, several years ago, a FDA new era of smart areas food safety, and as you can see, we actually delivered tools to the FDA. They of course never told us what they did with them, but they seem to actually implement some new pilots exactly around seafood and using AI, and we suspect that these tools potentially are being used currently. We actually currently talking to them about the next phase of this collaborative effort. So we'll see what happens. The FDA is a pretty slow organization. I don't know, those of you that if you ever interacted with them. So with that, I want to switch gears and talk about some work we've been doing in China from 2016 under the Walmart Food Safety Collaboration Center, which is an initiative that Walmart Foundation launched in 2016 as their next sustainability effort, and we were one of the two first grantees of this center in Beijing. So until recently, until the last year, we were going to China every 3 months for a week. It's a pretty elaborated project that involves multiple faculty at MIT. We actually have faculty from 3 different schools: School of Management, School of Engineering, and School of Sciences, many disciplines from regulatory science, artificial intelligence, supply chain management, biomanufacturing, food science, and so forth. So it's a very multidisciplinary team at MIT, but also working with 5 different organizations in China, including universities, research institutes, and private companies. And that never worked before until this project. So their collaboration with each other is actually through the work with MIT. Part of the funding that we get is also to give the sub awards to some of these Chinese collaborators. So and again, this is being funded by the Walmart Foundation. And just to give you a sense, we were very much on the ground here. This is on the right hand side here. This is a research meeting with kind of 40 people in China. This is a conference in Shenzhen. This is the head of the China FDA in Shenzhen. This is me giving a talk there. This is us in Wholesale Markets in China, very much on the ground. And sort of what I would like to talk about is really about how to use, again, data, that both large-scale data as well as field data, to inform some innovative research, and then see how to translate this to actually concrete tools, right? And not only just papers, academic papers. So let me talk on the first thing. And so surprisingly, in China, when you look at their laws, there is actually a law that mandates the regulatory organization, and China FDA has recently transformed to a different organization, but I'm going to stay with China FDA just for the sake of this talk. But currently it's being called a different name. But they are mandated to actually post all test results of food products in the public domain. That's a mandate by law. It's mandated by law. And the challenge, though, is that the regulatory structure in China is so distributed that you have on one hand the central CFDA database that is relatively structured, but then you have for each province and for each prefecture, and there are 32 provinces and hundreds of prefectures, each one of them has its own website and it posts its own test results with its different formats, free text, completely unmatched to each other. So currently this data resides on hundreds of websites in a completely different format that is not very usable. So we were able, basically with a team of 2 people, create a range of AI and machine learning and natural processing, natural language processing, to basically be able to scrape most of the data from most of the websites and create a database that is updated on a regular basis. Currently, we already have more than 5 million records, integrating different 75,000 different files and 15,000 different unique data tables. And let me just give you a better sense of what does it entail. So the next few examples, on the left-hand side, you will see how the raw data looks like, and on the right-hand side is you're going to look how the data set that we created looks like. So this is a raw data that basically says that the test was conducted in some supermarket in some city, right? And we, in an automated way, were able to identify that this is a supermarket and the name of the city, right? So we can sort of identify the supply chain location of the test and the city. This is a name of a food product, and we are able to identify the product category in an automated way. This is a failed test that had detected multiple other trends, and we are able to identify the other trends and the reason why it failed. Okay, and it's all being done in an automated way. 2 people manage the entire pipeline. It's being updated on a regular basis and create really a unique data set. So let's just give a few examples of what you can do with this data set. So what you see here, and one of the product categories we focused on are freshwater grown aquatic products, which is one of the high risk product categories in China, partially because the Chinese like to buy and consume live. They like to buy their fish live and their seafood live, right? And this is a schematic, simplified version, diagram of the underlying supply chain that starts with millions of farms. Most of them are family-owned farms, household-based farms, small farms, millions of them, through brokers that go through manufacturers and brokers, and then a lot of it goes to large wholesale markets, and then from there to secondary markets and wet markets, and finally to retailers and restaurants. Now, the China FDA currently primarily tests in retail stores. I'm going to get back to this in a second. But what we wanted to ask ourselves is not where the problems are detected, but more where the risk is introduced into the supply chain. So let me just give an example. Let's say that you had a test in a retailer store that ended up with finding residues of antibiotics. That's likely to be added by the farm. But if it was, let's say, a dye, it's more likely to be added by the manufacturer and so forth. So we were able to do, in an automated way, analysis for every failed test, where it's likely to be the source of risk in the supply chain. And what you see here is the aggregated risk. So most of the risk comes from manufacturer practices and farm practices. Some of it comes from the environment, and some of this comes from the transportation part of the supply chain. But one thing that immediately emerges from this is that the current testing scheme of the China FDA is not testing close to the source of the risk. And that's an immediate major insight, right? That in a second, I will try to make even more specific, okay? So that's kind of a high level supply chain analysis. That's kind of one thing, but let's just try and translate this to something more concrete, right? So let's assume that a product by a manufacturer were tested in a retail store, and there was a detection of basic orange 2, which is a food dye that likely to be added by the manufacturer, right? If you're doing risk-based testing, this should trigger a test at the manufacturer site to actually eliminate the risk at the source, okay? Now, when you actually look on the data, it turns out that we have 5,000 examples of manufacturer products that were flagged at the retailer store because of an adulterant likely to be introduced by them, but only 20% of them were tested on site, right? So most of them were not tested on site, right? And then, but when you compare the failure rate of these 1,000 manufacturers, the failure rate of these tests 6 months after they were flagged is actually about 3 times higher than the failure rate across all tests conducted in all manufacturers in our database, right? So what does it tell you? It tells you that this is actually likely to generate a higher detection rate of problems if you actually use historical data to actually inform the next test of where you want it to be tested. And the reason why the China FDA cannot do that currently is because they don't even have the data integrated, right? Like it's all over the place, so they cannot actually marry it together. So we actually translate this to an interactive tool that really allows you to see all the high-risk manufacturers that were not tested, all the red dots, and you can actually click on it and see all the details. And that's something we already showed both to companies and to some officials in China, and that generated a lot of interest. So we are currently working with, I mean, COVID came in between, but hopefully we'll get back to those discussions relatively soon.
Quick question for you.
Yeah.
If you go back to the previous slide,
yes.
So where the statistics are, if you've got these stats, are they being generated from the work that you've done? Because
what is generated from the work again?
I think if you press the animation forward a few to compare like the 3% versus the 10%.
Oh, okay. These are all data in our database, so we are not generating anything, but we are looking on manufacturers that were flagged here and were tested 6 months later on site. They generated 10% failure rate.
Yeah, and it's just kind of shocking in a sense, because like, well, why not just go to the manufacturer? If you see that.
Oh, well, but because if you don't have the data, think about it. This store can be in a completely different province than this manufacturer. So the people that are responsible to test this guy may not even know about this failure rate, right? This failure, right? So yeah, you're right. If you have the data, it's obvious. But if you don't have the data, it's less obvious, right? So.
Right. Yeah.
Okay. So I'm not suggesting that we have a major insight once you look on the data. I'm just suggesting that the data is giving you some obvious insights that you better use, right?
You need the data then.
Yeah, but it's kind of hard work to create the data, as I explained.
Yeah, that's actually one of my questions. How is data collection sustainable? 2 people.
We have 2 people that do that on a regular basis with a lot of automation and a lot of AI algorithms. So that's the power of AI, artificial intelligence. So. Okay, so I want to move on. So another thing that is very central in the supply chain, and actually quite unique, is the existence of these large wholesale markets. These are large distribution centers that do not usually exist in Western supply chain in the US. And they actually serve as a consolidation point for many product categories. So if we think about fruits and vegetables and seafood and other important product categories, about 70 to 80% of the supply goes through these wholesale markets. And there are only 5,000 of them, less shy of 5,000 of them. And that's a big opportunity, because if you think about the millions of farms and the millions of stores, it's actually almost impossible to regulate that. But if you have 5,000 locations that can regulate 80% of the supply, that's actually an opportunity. And it's also an opportunity to create transparency to the supply chain. So unfortunately, when you actually look on how the FDA currently, China FDA allocates its test samples, there is actually emphasis on retail stores, as I mentioned, and actually relatively little attention to wholesale and wet markets. And that's in spite of the fact that, as I said, most of the supply actually does not go to retailer stores. It's actually go to wholesale markets and then to wet market. And when you actually look on the failure rates in wholesale market and wet markets are actually significantly higher than the failure rates at retail stores. So again, this is again an example that once you are able to put the data together, it gives you immediately a signal that the current resource allocation is not optimal from a risk perspective. Now, it's not obvious that you immediately want to shift things from retailer stores to wholesale markets immediately. You have to think about the endogenous aspects of this, that as you shift resources, potentially the adulteration rate is going to change. I can tell you that even when you actually accommodate for that, you actually see that you have to allocate more resources to wholesale markets and wet markets. But frankly speaking, wholesale markets and wet markets are interesting not only from a food safety perspective, but actually they're also a source of zoonotic diseases. In fact, almost all the pandemics that came out of China, and there were a few of them over the last several decades, are associated in one way or another with wholesale and wet markets. So what we wanted to ask ourselves is there a correlation between food safety risks and zoonotic disease risks? Okay, and in order to do that, we wanted to first develop the ability to understand the risk at the market level, at the single market level. And that's actually quite challenging. If you actually think about what you need to do here, we go back to our data set, but it's actually not obvious how to allocate every record to a specific market. And the reason is that the way that they call these markets is completely non-standardized and completely unstructured. So in order to do that, we had to actually develop a very innovative unsupervised clustering that was allowing us to, in a very accurate way, to connect each record associated with a specific market. And that would allowed us to actually look on all the records associated with a given market and score it based on the failure rate in those tests. And then we lift the market risk level scores to a province level risk score. And then we were trying to see if there is any correlation at the province level between how much supply goes through high risk markets and how many flu isolates, zoonotic flu isolates were detected in that province using an international database of flu isolates. So that's kind of what was the roadmap. This is just a high-level description of our clustering algorithm. It actually gives you a very high accuracy. So we are able, when you do manual review, we actually are able to allocate records in a very reliable way to the market level. And again, this is immediately translated to tools. So what you see here are all the markets, or many of the markets in China, and their scores. So the red is high risk markets, and the brighter ones are less risky markets. And when you actually look on the province level risk scores versus the isolates, the number of zoonotic flu isolates detected in each province, you actually see correlation even when you control for other variables. And when you actually think about that, one of the hypotheses that emerging is that there are similar common system level environmental and management deficiencies in wholesale markets that could actually drive both risks of food safety as well as risk of zoonotic diseases. Think about things like sanitation, infrastructure, and so forth, right? But this is actually a pretty big insight, because currently, if you think about those two types of risks, that are being managed by completely different bodies and organizations, right? So there's no integration in the way that this is being managed. And it's, again, another reason to sort of think very, very strategically about how to design better management schemes for wholesale markets in China. And that's kind of a project that we currently work on. And in fact, one of the things that we've done already, we actually conducted a major field survey of 3 provinces in China, where we actually surveyed all the aquatic wholesale markets in China, in these 3 provinces. It's maybe the largest field survey of wholesale markets in China ever. And we're currently working with a few wholesale markets on pilots that will try and implement new approaches to actually manage wholesale markets better. And that includes, among other things, testing, new testing capabilities. Because if you actually think about some of the challenges in managing wholesale markets, that the food moves through the wholesale markets very quickly. So you actually need to develop rapid testing that has accuracy that allows you regulatory action. And that's something that currently does not exist with a rapid testing capability. So part of our team is actually developing testing capabilities, new testing capabilities to test food. That's maybe a discussion that we can do offline. We also want to use that to create transparency, better transparency on this in the supply chain by lifting all the transactions in the market into digital platforms. So that's kind of another direction in this effort, and that's kind of something that we currently work on. Another aspect of that is essentially prioritizing the risk in markets, but not only in markets, but also food, the specific fish types and the specific product types. And in fact, in a pilot that we run in wholesale markets, when we used risk-based approach to inform which fish types you actually sample, you actually, again, can increase, it seems that you can increase the failure rate detection by a factor of 3 to 6. So again, that's another example of risk-based regulatory activities. So I'm already over time, but let me just conclude very quickly. I just want to point out that if you look on the policies that come out of the Chinese government, that they actually emphasize exactly the directions I was talking about so far: risk analysis and supply chain management based food safety regulatory system, and emphasis on managing the wholesale markets. I can tell you that these are things that happened after we started to work, and I have a sense that we potentially helped informing that. But it's very encouraging that what we are talking about now is now aligned with the policies or the priorities of the Chinese government, because that gives us hope that they will be willing to fund pilots and hopefully use some of the tools that were developed. So just a summary, hopefully I gave you a sense of the potential of analytics and supply chain analytics in particular to actually inform regulatory work. We talked about the notion of identifying high-risk companies, identifying high-risk supply chain locations like wholesale markets, and identifying high-risk specific products within a product category. There is a lot of potential of leveraging technology here, both at the level of IT platforms as well as testing and rapid monitoring. And again, the interesting connection between zoonotic disease risks and food safety is another direction that we are exploring now, including modeling this from a perspective of why wholesale markets and wet markets are such a source of outbreaks of zoonotic diseases. Potentially there is an epidemiological explanation to that. And let me just end up by giving you a better sense of an initiative that we launched a year ago at the MIT Sloan School of Management that covers beyond what I just talked about today, which is here in the middle, other aspects related to food supply chains like access to healthy food. And I know that many of you are dealing with the right-hand side here. So I'm happy to discuss that aspect related to that in after the talk. And also how analytics and data can be used to optimize the design of agriculture and food markets, as well as agriculture practices. We have several projects, including in India, on the ground in that space as well. So with that, thank you for your attention. Sorry for taking a little bit longer. I'm happy to answer a few more questions.
Thank you very much.
I'm going to stop sharing so I can see all of you in a more, okay, now I see everybody.
Great. So we have Zhihao Chen has a question. How do you think vertical farming will affect the food supply chain and food safety?
So this is very interesting. So I think China traditionally had farming supply chains that are based on family-based farms and structures that's called that is based on these large companies that contracted with many small farmers. They are trying to push, and they try to push over the years to vertically integrated supply chains. This is facing multiple challenges. One challenge is that the land laws in China are not allowing you to do that in such a transparent way or easy way. But the second challenge is that if you think about the US and these large farms that we have, they typically are located in very unpopulated areas. And in China, most of the farms currently reside in highly populated areas. So it's actually not obvious that by creating these large vertically integrated farms, you're not going to create environmental hazards. So it's not clear to me that the model that we have in the West is necessarily the ideal model for China, and potentially the right direction for China is to go in directions where you actually are able to integrate these small farmers in different structures, but still keep the individual farmers, but in a more regulated way, in a more kind of secured way that both give them the support as well as protect them from risk, which are, you can actually show that a lot of the behaviors that you have at the farm level are because they don't have the knowledge and the support, but and or they are being exposed to high risks that they have to just react. We actually wrote a few papers about that. So I think that it's not obvious that all the time the solutions that work in the West will work in China. I think we might need to think about other solution approaches. Other questions?
On mute. Tim asks, what about private incentives to adopt blockchain technology for traceability?
Yeah, well, blockchain is a buzzword that is being heard not only in food supply chains but all over in China. I am kind of more dubious about that. What is it? Essentially, blockchain is essentially like digital aspects of the supply chain. But what it doesn't solve is the incentives to actually put the right information there, right? So I think you need to first solve the structural problems before you actually think about the blockchains. And once you solve the structural problems, which are gigantic, then I think that creating the digital infrastructure to allow you to collect this information, I don't think that that's going to be a big challenge. This technology is relatively simple. I think that the major challenges is understanding, mapping the supply chains and making sure that they have the right incentives and the right structures to really ensure that most of the data that you get is actually reliable. If you ask me, that's kind of my take on that. So I'm not that hot on blockchain solutions, especially not in places like China. So.
Alexis?
Yeah, roles of certifications. Yeah, well, there are some certification programs in China. I think that the details, the devil is in the details, right? Like the question is, to what extent these certification really represent actual actions, and how do you make sure that it's happening? So I think it's something reasonable and sensible to pursue, but I think that the issue is not the certificate. The certificate should be the outcome of changing practices. If the certificate is a true mechanism to actually impose change in practices, then I think it's a great direction. But more often than not, you end up with certificates that do not represent real change in practices, and then it's not obvious what is the value of that. So I think that the challenge again is like, can you have it with teeth that will change practices, is not only just stay at the level of certification.
I think, just kind of more of a comment. I think the whole idea of traceability is kind of just hard for me to wrap my head around because, just looking at some of the data that the CDC puts out, in the United States, I think it's through their like outbreak reporting system. And if I put together a lecture yesterday on food safety, and I was diving into some of the data, and it's so spotty. And an outbreak only requires 2 people to report an illness. And to me, it just doesn't. There's so many other questions about, when you talk about, having that more standardization with this. So I think that
absolutely, I think that if we think that China is just like a developing country and the US is great, we are not great at all. If you think about the outbreaks let's say in Arizona from green leaves and stuff like that, you have exactly similar problems. It's actually a much more solvable problem than I think than the problem in China, and nevertheless, somehow we are not able to get our act together. I mean, it's beyond that. Like, one would hope that when you think about, so for example, the last outbreak came from a contamination that probably came from a cattle site that was near a green leaf site, and brought the salmonella probably into the lettuce, and sort of, yeah, these sites are not a secret, right? Like, if you want to do strategic risk analysis and food safety management, you should know where the farms are, where the cattle sites are, where the water tunnels, right? Like, this information exists, but nobody has the incentives or the resources to bring it all together. And I think in that respect, I just think that we have a lot of opportunities here in the US, because I think it's doable. It's just a matter of changing our mindset about this. So, but yeah, if you want to look and you want to map today the supply chain, nobody, even the industry organizations, don't know the supply chain. It's like the FDA doesn't know the supply chain. This is why every time they start an outbreak, they basically have to close down and recall, in a blanket manner, like, just like, hey, let's just recall all lettuce. The economic damage of this is unbelievable. And it's, but it's the incentive of everybody to create transparency in the supply chain, but somehow it still doesn't happen. So
yeah, and for industry too, they have to consider the,
if I'm the farmer, I don't want to be, if I'm okay, I can be perfectly okay, but because there is lack of transparency and they don't know what the source of the problem now, they're going to recall my products as well, right? Like, I'm going to be now screwed, right? So yes, but someone has to be willing to pay for that. So to create transparency.
But I would argue that mapping the supply chain only gets to part of the problem, because agriculture is an inherently messy business. You think about the E. coli outbreak in spinach in 2007 that you alluded to earlier. That was a wild animal. So you can map all you want. You're not going to map all wild animals that spread these things from farm to farm. So
actually, the last one, it's not the 2000. The last one was actually not the wild animal. Was it like cattle?
No, I'm not saying the last
site.
one. This is a big one back in 2007 that almost shut down the spinach industry. And it took them years to recover from that. People wouldn't eat spinach for ages. And you alluded to that sort of long-term damage, but that was a wild animal.
Yeah, but if I know if I can track back each product to their source, then I can sort of immediately see that it's coming from a bunch of farms and not from other farms. So I can sort of more safely decide that I don't have this blanket action. I can have more targeted action, right? So it's not only the prevention. I'm talking about the management of an outbreak like that. Currently, when you have an outbreak, since you don't have traceability, you have to really go say, okay, this is recall all green leaves in Arizona, right? Like, or whatever. Like, if you could do it at the farm level or at the area, at the region level, you will already have a significant improvement compared to what we currently have. It's not going to be at the prevention level. It's going to be about being able to mitigate in a much more targeted and rapid way. By the way, it also takes you sometimes weeks and weeks to even get to a broad area. It can take you now 4 weeks. If it took you 1 week or 3 days, think about the economic value of this, right? Like, it's tremendous, right? So yeah, I agree with you. You will not, I'm not suggesting that you will prevent every problem, right? But I think that you will be able to manage problems in a far more efficient way, right?
Yeah, I guess my argument is that it's part of the solution and not the only solution. The fundamental idea here is you want to align farmers' incentives with the public policy incentive, right? You have to make it in their best interest. And we lost so many spinach farms during that time that I would suspect, and that was the whole origin of the FSMA. That's where it came from.
Yeah, I agree with you. So I think that, and that's also true in other places. Welfare, farmers' welfare and farmers' incentives to do the right thing, including, for example, testing your own farm. Currently farmers are afraid to test because if, let's say, they find something, it might actually compromise them, right? So they don't want to test, right? So therefore, you don't have traceability, right? So I think that farmers' welfare is key aspect to have safety. If you have farmers that are compromised economically, expect food safety problems. Like you just expect that. So
here's a question. I was thinking as you presented your findings with respect to the the work you did with the FDA. it strikes me that there's an element of something like the Lucas critique here in economics. Just the process of observing something means that you won't be able to observe it in the future. By the FDA publishing it on the website that this is, if we identify these companies that are, that import pianos and shrimp at the same time, you're more likely to be tested. Companies aren't going to do that anymore. So you're not going to be able to observe that, and you're not going to be able to use it.
Yeah, so that's a great comment. So I think that it's great. So I think that the point that I was trying to make is, first of all, I'm not sure that you want to publish what you're doing, but regardless, I think that when you want to think about how to use tools like that, and again, it requires detailed optimization, but at the high level, you need to do two things. You need to do, part of what you do is guided by risk, and part of what you do is random exploration. And this way, you accomplish two things. A, you keep everybody on their toes, and B, you actually adaptively learn what are the new ways that the other side is doing in order to actually evade your inspection, and then you adapt your models, right? So by no means, I think the conclusion should be, oh, we created this model, now we put it in, and now we are happily, live happily after. It's an ongoing chase, and it's almost like an intelligence work, right? It's not almost, it's actually in an intelligence work where you have an enemy and you have to adapt yourself to what the enemy is doing. In the same way, let's say that you start testing for certain antibiotics and you start detecting, and what do you think the farmers will do? They're going to switch to another antibiotic. So, and usually, currently, most regulatory organizations do not do thinking about the next step, the feedback loop that you're going to get. So basically say, hey, let's just look on similar antibiotics to this functionality-wise, and let's just test for them, at least exploratory, right? These things currently do not exist in a very evolved way in among regulatory organizations, including not in the US and definitely not in developing countries. And this is exactly the next level that hopefully data can bring you there. So, but absolutely, you're right. It's a dynamic. I think the big takeaway from what you say, it's a dynamic act rather than like a, okay, I'm doing something and now I solved the problem. It's not a bang bang, right? So
right.
Yeah, I think it can definitely help on new issues that are arising, like cadmium content, heavy metals on food, right? So that will definitely help on traceability, and eventually farmers will have to test their soils, and that's something that they cannot run out. They cannot change their soil.
Yeah. So frankly speaking, in this context and many contexts, including the recent pandemic that we had, I think that what we are missing in many countries, in all countries, and definitely in the US, is what I would call a public health intelligence organization. Just as we have military intelligence, such as we have foreign affairs intelligence, I think we need to have a public health intelligence. And part of what that organization will need to do is to monitor risks that evolve, right? As I say, it's a very dynamic world. Risk will evolve both because of environmental change, bad actors that develop new ways to evade regulatory actions, and so forth. And you need to have the resources to monitor that, develop appropriate actions, and go after the bad actors. And I don't think that currently we have the ability to integrate efforts across that or build expertise. If you actually look on what the CDC has and what the FDA has, these are very weak organizations in terms of data, very weak, and intelligence. They are more lawyers and scientists, right? Which, it's also, you need that, but they don't have the concept of intelligence and data in a very evolved way. And I think that that's missing. That we saw that also with the COVID-19 outbreak in many respects. So I think it's something broader than just food, but including food in a very major way as well.
So are you working with USDA on this as well? As you know, the food safety is kind of a weird thing. It's like antitrust law, right? It's the FTC and the US DOJ kind of split things up, and we know that USDA has responsibility for meat, poultry, and eggs.
So we had some connections with the USDA and some discussions. We didn't have a contract yet, but we are talking. I mean, it's sometimes a matter of opportunities in terms of funding that they have. I mean, the other problem with the USDA is that many of their grants require matching, which is they require the university to match, or the organization to match money, and that kind of complicates things very much when you want to, at least for MIT, it complicates things. So So yeah, we were exploring a few opportunities. Some of them we submitted a grant and it didn't go through, and some of them we were just deciding that the complexity of this matching mechanism is just like not something that we would be able to manage in the university. As you can imagine, in university, you're not free to make only decisions that you want to make. You also have to respect the landscape of university regulations.
So I think this is a good place to pause and let folks off the line if you're not sticking around.
Thank you very much for the attention, the good question, really good question. Thank you guys. So, appreciate the opportunity. I need to still to learn to read the comments, the chat. So.
Hey, Dr. Levi, I'm John Lowry.
Hi.
Nice to meet you.
You are the guy that goes to Northeastern?
Yes, yeah. I've
read the bios of everybody. I've kind of searched. I don't like to come to meetings when I don't know who I'm going to talk to. So.
Oh, neat. Yeah, neat. Wow.
So I read about all of you. So
neat.
Maybe it's going to save some of the introduction. So.
Yeah, so I've been in touch with Elizabeth, and here she's going on Stanford for a postdoc before HBS.
Yeah, and she's going to Harvard. Yes, Elizabeth. Yes. Do you interact? She told me that she interacted with you. Yes.
Yeah. So I listened to Elizabeth's presentation at that virtual Kellogg presentation, and then I saw Nick give the talk about diseases and the CFDA and all that other stuff.
Yeah, both of them are great.
Yeah. Great little lab group going on there.
I'm as good as my students, as I say.
Yeah, really great presentation. So, are you familiar at all with this guy Matthew Lang from UC Davis, who's creating this the hypertext food markup language? So it's like this idea that one of the barriers to adopting traceability in supply chains is a lot of standardized languages, and these labeling kind of mishaps and like policy kind of that needs to be through so that like all constituents along the supply chain are using the same language and the same kind of standards to monitor and evaluate.
I didn't hear about it, but that sounds like an intriguing idea. I mean, it does sound that it addresses. I mean, I need to understand more details, but it on the face of on the surface, it looks like an interesting direction to address a problem that definitely exists currently, because a lot of the data being collected currently is completely unstructured, and it's very, very hard to actually put it together.
Yeah, and really understand it. I mean, like you said, with the study of these consignees and bill of ladings, that was one thing is how much of the consignees really indicate risk for these companies that they work with, because I would imagine
I can tell you that the problem of the FDA is far more basic. They don't even know what the sites that they need to inspect, that the address, whether the address is correct. So it's like they don't even, it's amazing. Like at some point they ask us, can we bring them the publicly available data? And it's like, hey, it's just a subscription. Like, I guess the government, like, why don't you just ask the port authorities that collect to give you this data? Like, well, that's a big. It was easier to try and get it through us. Like it was like, okay, what's going on, guys? So. But I can tell you the data quality that the regulatory organizations are working with is just like, it's abysmal. It's just like very, very bad. So,
well, you mentioned something too about the in China, the one of the challenges is that they're operated by two different agencies. And
well, in China, the regulatory structure there is far more than just, so first there are two agencies like similar to what we have. We have USDA and FDA. They have the Ministry of Agriculture and the now it's the AMR, but it used to be the China FDA. But the more significant thing is the fragmentation at the regional level. Like basically every city every province has its own regulatory organization, and they're not very well integrated. So even within the same province, if you actually look on two different cities, you might have practically speaking, a different regulatory environment. The enforcement could be different. Even the rules can be different. That creates a major challenge for China, because as I said, when you look on the rules, like if you look on the written rules, they're not that different than any Western country. It has all the right elements, but enforcement is and transparency to where the problems are is a far bigger challenge for China. We think about China as a very centralized place because of they are not a democracy, but it's actually in many respects is a far more fragmented and distributed management if you compare to the FDA, which is a very centralized organization, right? It's very much centralized, right? Versus in China is much more distributed.
And fragmented things.
So that's kind of a surprising insight that you don't know until you start going to China. So it's like
right. Yeah, no, and just
Lina, are you from China originally?
Yeah, Professor. I'm from Chongqing.
Okay.
Yeah, very nice to meet you. I'm
my
in my 5th year from the Department of Supply Chain Management. Yeah, actually, I was very interested in the topic you're talking about. I read your management science paper. It's fascinating. So I have a question, actually. I used to work for Walmart in China.
Oh, okay.
So I understand there's a big incentives for retailers to do the testing right. So for example, when we source from shrimp companies, or
$50,000 fine they get every time that they have a violation. So that
exactly, buyers will be on it all the time. We were visiting suppliers on site.
Yeah.
So I think this incentives is really high. As you mentioned that there's 200 million suppliers. So when you tested those small suppliers, how efficient it will be, for the resources.
Yeah, it's a big problem. If you actually look on one of the slides that I showed, it actually looks like the retailers are able to take the better supply from the overall supply. So basically, the problem is the incentives play like that basically the better, safer products go to retailers because they test more, and the less safer goes to wet markets where there is, basically very spotty testing there. And again, I think that if you ask me, I think that the major change that China needs to have in its regulatory approach is to test close to the source of the problems. When you test close to the customer and you test at retail store, it's just too late. Like at that point, it's very hard to track where the problems are. I think that testing near the source of the problem, at the source, then you actually eliminate the source, the introduction of the risk into the supply chain. And I suspect that doing it in wholesale markets will give them a big advantage, because if you tell me that in China you can actually cover 80% of the supply in 5,000 locations, that's a sweet deal. But that will require a complete change in the mindset that they have. But I think I suspect that they are going in that direction. So I suspect in 5 to 10 years we're going to see a big difference on how they manage wholesale markets, and it's going to become a much more digitized infrastructure that they can sort of track what is happening, and so forth. So, but that's my hypothesis. We'll see what happens. So.
Okay, great. And I suspect that it's really hard to centralize the capability of testing, because
I think that it's going to have to rely on the provinces and the prefectures working based on some guidelines from the government and maybe some funding. But I don't think it's going to be implementable by centralized effort. And essentially, nothing in China can be centrally implemented. I don't think it's like just too big.
Yeah, so there's a lot of resources need to be engaged in this effort.
That's for sure.
Okay, thank you.
No, thank you.
So is all of your work, Retsef, involved with regulatory agencies and things like that, or do you actually have some partners? Do you work with Walmart and things like that to avoid the kinds of fines that you're talking about?
Yeah, so we worked a little bit with Walmart. We actually are also talking with multiple companies. We actually, in all likelihood, our follow-up after Walmart will actually be will be funded by West Hope, which is a big poultry and other food producer in China. So yes, in fact, in China, most of our work is actually with universities and private companies rather than with the government. In the US, it was with the FDA, but we're now talking with other private organizations. We are working also with the state of Massachusetts on issues related to access to food, which is not food safety. But no, we are, I mean, in order to solve problems like that, you need to bring together academia, industry, and government. There is no, so my vision is to be able to create consortiums on topics that really engage multiple universities, multiple industry stakeholders, and the government. But you know, COVID was a big disruption because nobody is paying attention to anything now, and so I think it will take at least 6 months to 8 months before people will go back to now let's just go back to do some normal stuff. So.
Yeah, just from a general perspective, you know, that question kind of comes from, you know, as an economist, Lauren and I are economists, and everybody else in the Morrison School mostly is an economist, you know, and we go to our, you know, agricultural and applied economics meetings, and we talk about these issues all the time, right? And there's like maybe 1 or 2 sessions that deal peripherally with supply chain issues. Then a couple of years ago, you know, your work and, you know, other people and things, I just realized how much they're doing in supply chain itself about food, and it's pretty exciting, right? And to me, the major, I guess, you know, the most refreshing thing about that perspective is that it tends to be looking at things from a firm perspective and looking at these things from the perspective of how can we optimize our systems to avoid these sorts of problems in the first place. You know, the sorts of things that you're talking about regulating. You know, I think that's a really great way to look at it, as opposed to sort of the, you know, top-down, you know, view that we usually take about these problems in economics.
Yeah, I mean, let me just share 2 thoughts. First, I'm actually at MIT. There are a lot of economists, not in agriculture economists, that look on the organizational level and actually study organizations and believe that economics is not only about markets, but also about enterprise. And I would agree with that. But honestly, I think that we all have our discipline that we were trained in. But at the end, when we want to solve a problem or think about the problem, problems in the world do not match the disciplines of academia. They cut across them. So I think that this is why the secret here is both create teams that bring multi-disciplines into the table. And also all of us, just basically, I need to learn economics. Economists needs to learn supply chain if they want to understand those issues. I think that otherwise you're going to, you know, you're not going to be able to explain to yourself what you see and or think about solutions if you don't bring all of these disciplines together. Economics, supply chain, analytics, regulatory science, right? I mean, the technical aspects like how you test, right? What you can detect, right? So I think we just need to be more problem driven and just bring either through people or through ourselves, like integrate, like learn new areas that maybe we didn't have our PhD on. To be able to think about those problems. There's no one discipline, including not supply chain, that would be able to encompass the complexity of problems of this kind. Right?
Couldn't agree more.
Dr. Levi, what do you see as the role of supply chain in the study of food waste? I know that
most of it is because supply chain deficiencies, right? Like and perishability.
Yes,
so
from more of like an academic kind of journal perspective. I mean, I know that AUKUS is pretty heavily involved in drivers of food waste, identifying kind of properties of retailers and how they can solve this food waste challenge. But there's not a lot of stuff in our journal set, in the supply chain journal set, that really is focused on.
I think that actually there is a growing literature on supply chain waste, definitely at the retail level. I think it depends. Well, I think there is waste in consumer level, so, the retail level and the farm level, right? I think we need to. I mean, and they are not unrelated. I think we need to understand again what are the economics and supply chain mechanisms that currently drive those waste. For example, at the farm level, many farmers don't have, because the way the risk is currently being allocated in the supply chain, they are usually don't have transparency to opportunities to sell the product, and they leave them to rot in the field. They don't even harvest, right? There you go, maybe 30% of what they grow, right? And some say more, right? So I think that this is another area where I think that understanding first that, we are missing even the diagnostic piece, right? I don't think we can characterize yet what are the underlying processes and dynamics, both commercial, economics, supply, like that cause waste. I have my own hypothesis, but I'm going to be honest, I did not validate them with any real data because I don't think we even collect data appropriately on this. And I think that once we understand this, we will be in a better place to start designing policies, supply chain structure, incentives to allow us to mitigate that. The problem is currently that we very much sometimes do some ad hoc stuff without thinking about the feedback loops, right? And then, or whether it's scalable or whether it has the economic sense, right? Like you can do, for example, there are many stores that bring, that try to sell discounted food to impoverished. Most of them go bankrupt because they have to rely on fundraising, right? Like that's not the solution. That's not the solution. The solution we need to create a situation when it's going to be good business to sell vegetables to this population. There should be maybe not the most profitable business, but it should be at least a break-even non-profit business, right? Not-for-profit business, and not like depending on charity, right? If it's going to be depending on charity, that's not going to work out, right? So that's at least what I believe. So when people come with all of the charitable efforts, like it's nice, but that's not a solution. And sometimes it kind of gives you a fake sense that we are solving the problem while we don't, not in a sustainable way.
Can you talk a little more about what you're doing with respect to like the access to healthy foods? So, we talked a little just now about food waste. So what about the, food deserts?
Yeah, so there are multiple efforts. One of them is to try and understand again so I think that if you think about what governments did, at the high level, you can sort of think about financial interventions that basically try to make food more healthy food more affordable, in the sense that they give you stamps, they give you rebates, right, so forth. Then there is access, physical access, that has to do with building stores, adding farmers market to the program, right? And then there is education, like basically how do you actually make people believe that that's the right thing for them and make them engaged in trying to get the access food. And I don't think that we understand the bundle, so I think that there's some understanding of each one of them separately, also partial, but we definitely don't understand the interactions between all of these interventions. And we also don't have a behavioral model that you can actually understand from data that capture heterogeneity in the population. So, it's fair to assume that one household is not like the other household, right? And maybe the interventions that are going to be effective for this household are not going to be necessarily effective to the other households, right? But I don't think we have a concept of, okay, I'm looking on household, what are the parameters that I want to look at? So will tell me what is likely to work and what is likely not to work. So the work we've been doing, there's a modeling aspect of that. So trying to build what I call a choice model of how households, based on their characteristics, make decisions about what composition of food to consume, given them how much money they have, given what is this utility to go to the store, given, and then I think that the other thing is to basically then see how you optimize interventions. And there's some interesting insights that basically, in spite of the fact there is a lot of heterogeneity, actually with a relatively coarse segmentation, you can actually improve things significantly. And then we also worked more on the ground with the department here in the state, at the state level, about trying to understand some of the design issues when you actually want to design a stamp program that tries to incentivize to consume more fresh vegetables and food. And it's surprisingly, you see programs that even when they have the budget, the engagement is very low. So you have to ask yourself, what is causing this low engagement? Is it just value? Is it just like access? I don't think we still have answers. We don't yet have answers to those questions. And I think this is a very exciting area of research. So.
Right. I think it's probably also one of the more complex ones because you talk about interdisciplinarity and, you know, I try to.
Unfortunately, exciting is usually not trivial. Otherwise, people would do it.
Yeah, no, it's just hard because, yeah, you've got all these folks involved and everyone's, you know, as an economist, I'm thinking about something in one way. And then on the advocacy side, it's really hard for me to come to the table and engage in a, you know, a conversation.
Can I say something, Lauren? It's my own bet. Don't say as an economist. You're not an economist. You're a person with a brain, and you know economics, right? And you know other stuff, right? So
I know a lot of things.
Why do you want to think about the world as an economist?
Incentives and opportunity costs.
Why do you want to think about the world as an economist? Think about it as a person, like that has brain. So.
And it's, you know,
sorry if I'm like attacking the discipline notion of academia.
Well, I think the more broad point that I'm trying to make also is just that, you know, when it comes to thinking about all the different policy tools that exist right now with respect to, you know, the subsidies, the access component, and even the education component, you know, yeah, behavioral models are one thing, but actually like operationalizing something that can then be affordable and sustainable is like a whole other.
Absolutely. I think that we are missing two major aspects currently. We don't have measurements. Mm-hmm. Actually, three aspects. We don't have measurements. Like we don't measure, we don't have a measurement concept of what do we want to measure, right? And usually measurement should be informed by a model about the world, about how the world behaves. Then we measure, then we update the model and vice versa, right? So we currently don't have that, right? And secondly, I think that we don't have a notion of that at the end of the day, it's not about creating a plan, it's actually implementing a process, a new process, and sort of that interact with humans, both as suppliers. And I think that we also don't have often that notion in how we think about it. So I just think that we need to create a model, and that model will have economic aspects, it will have behavioral aspects, it will have operational aspects. It's not going to be a model that belongs to one discipline. It needs to be a data-driven model in the sense that I can hypothesize what I expect to see and go measure. And if I don't see what I expect to see, I go and update the model and so forth and so forth. And I think that once we have that, we will be able to start understanding the phenomena that we see in a better way and hopefully intervene. But currently, it seems like almost like we are hitting blind in the dark, like without understanding what's going on, right?
Yeah.
Or maybe anecdotally understanding some narrow aspects of what's going on without understanding systematically what is going on, right? So.
Yeah, because on the topic of measurement, and you know, what's the outcome that you're looking for here? Because you know, we talk about health. Perfect. But what is health? How is that measured?
Perfect. I agree with you, but I didn't say it's trivial. It's hard, but I think if you don't answer those questions, it's very hard to move forward in a very rigorous manner, right? Yeah. If we don't agree of what are we even measuring, what is the outcome that we are measuring? What are we trying to accomplish? So how would you know that you're doing better than what you did before? Mm-hmm.
Yeah, and with food safety, it's fewer illnesses, right? But with food access,
even there, it's hard, right? Like because let's say if you increase safety, you're going to see less safety incidents, but it also can be the result of you're not looking in the right places, right? So you never know for sure, right? So it's actually the measurement strategy here is key, and it's actually non-trivial. And that's why we need to think about it hard, right? So. Mm-hmm.
Yeah, just on the measurement issue too, back to your presentation about food safety. I used to do a lot of work on invasive species, which is another, one of these intractable food related sort of problems. With billions and billions of dollars of largely unaccounted costs every year. And I was trying to think, there's a guy at University of Maryland who's using import data, inspections data that the Forest Service does, to look for invasive species. And you talked about using bills of lading and things like that. And then, to get to just so I can understand your process right, you would use these bills of lading to identify what was traded, and then you'd actually go inspect the facility directly, right?
Yeah, but that's what they did. Yes,
right.
They have to do that.
What about inspecting the shipments themselves?
Oh yeah, so we did. I didn't talk about that, but some of the work we've done with them was informing shipment sampling, and you can actually do similar work to inform shipment sampling. They do have some system that is called Predict, but it's very granular in the sense that it mostly looks on the current way that they think about risk is say, seafood is risky and seafood antibiotics is risky, and then maybe they will say China is risky. And then beyond that, they would just say, "Hey, you failed in the past one time, so you're now on the bad list, right?" But they don't have this next level, which say, "Hey, this is a pattern that characterize bad actors. Here's someone that behaves like that. We should inspect them because they look suspicious, right?" That level they did not get. I mean, the FDA did not. And the other crazy stuff is that this predicting is by a private company, and they don't even have access to the details of the model. They're using it as a black box, which is kind of crazy. The government is like, what? You cannot even know. So somehow they signed a crazy contract with a vendor that I still don't understand what is happening there. But I agree with you. I think that that's the notion of intelligence, right? Like you have some hypothesis, you create signals from the field, and then you incorporate that into your model to update the model and sort of understand where you are. That's intelligence, and I don't think that that's a concept that currently is very strong among regulatory organizations in the US and more generally, I think. So, I mean, the US is maybe one of the better cases.
So yeah, I got a question about this modularity function you're calculating for each of the consignees. Mm-hmm. Is it really just more of a ports themselves, whereby high shipment?
I couldn't hear. I couldn't hear what you said, there, John. You're coming in and out a little bit.
The variability of the products for consignees versus actual ports consignees are located at.
So the concept is you have the graph, and when you look on the products that the consignee is dealing with, the weights of the edges between these nodes represent how likely these products to be handled together. And the edges going from these nodes to the rest of the nodes is the likelihood of these products to be handled with other products. And to some extent, the ratio of the two is giving you some sense of how common the mix of these products is with each other versus the rest of the product. And it's a notion that we did not invent. We just borrowed the notion from graph theory that seemed to be appropriate here.
So my question would be, at these larger ports, are they consignees accepting kind of more standard loads?
Yeah, so the large importers usually do mostly seafood and fish. They don't go on other products.
So is it a function of the consignees or a function of the size of the port that these consignees
can use, many of these consignees are using multiple ports, not necessarily one. It's mostly the size of the consignee. If they have high volume of seafood and fish, they're probably going to do that mostly and not like other stuff, right?
Okay.
So do you have any questions for us that you?
No, maybe actually. So yes. So could you tell me a little bit what the work you're doing in the food space? I kind of read. I know that you're writing a lot about that, but and I scan the papers. But if you have any ongoing projects or things that you're doing, I'm happy to. I mean, I'm always intrigued to hear what other people are doing.
Well,
in fact, it's actually, I was surprised to see such a big community of people that do food-related work. It's actually not a very common thing in most business schools that I know, which is great. It was kind of refreshing to see.
I guess that was kind of the point that I was trying to make earlier, is that, when you had a graphic earlier in your presentation that showed like a flow chart of all the different things that you were working on with this same sort of approach. And the intersection between what I'm working on and what you're working on is about 80%. Food security, food waste, food safety, all these things, like I mentioned, are things that we've been talking about for years, and it's refreshing to see that supply chain people are.
No, I fully agree with you that I think that part of what I'm hoping to do is to expand my understanding of the community. And currently, it's not a very structured community because it's, most business schools do not have a food department, right, or agriculture department. It seems that you guys do, which is kind of unique. I don't think I know too many business schools in the US with a department like yours. Or maybe I'm wrong. Maybe there are more of that, and I'm not aware of that. So that's maybe my first question. To what extent the fact that your business school is organized in a way that has a clearly defined area of, it's called the agribusiness.
Agribusiness.
Right? So, yeah. So that's a department that I didn't see in any other business school, which is kind of say, oh, that's interesting.
Yeah, if you had 2 days, I could explain to you the history behind it, but I'm not going to bore you with it, other than the fact that you're right. We are somewhat unique. Cornell, the Dyson School of Applied Economics and Management, started as a kind of agribusiness school like ours. It's part of the SC Johnson School of Business. They've got the Johnson Graduate School, they've got Dyson, and they've got the hotel and hospital.
Oh, that's a new thing that they just
well, it's an old school. AEM
no, but they merged the three
yes,
of them.
My
PhD is from Cornell, so I have good intelligence of Cornell.
Yes, exactly. Yeah, what is it? $250 million for that? You can do a lot of merging.
Yeah.
With the floor cleaning company. But anyway, we have a lot of colleagues there that we work with all the time that do very similar stuff like that. But in general, other than that, the rest of our colleagues in applied economics are, at land grant schools, so they tend to be more kind of, production, farm, this sort of thing oriented from an economics perspective, and they're not really thinking about things in terms of the business angle on these food issues.
So they are more in agriculture schools. That's what you said, or food. They are, okay, yeah. And even agriculture is not it does not exist in many universities. They don't even have agriculture, right? It's not like that every university has agriculture, right?
Right. It's just the land grant schools. Every state, the Moral Land Grant Act of 1862 set up every state with an agricultural college. So most of our colleagues are in, there will be a small department within, plant science and animal science and all this.
But they're going to be much more technically focusing on the technical aspect of the agriculture aspect rather than the economics or the business or the system level design, right? Okay.
The ag economists are economists, so they think about that, but not, from a business.
Yeah, I actually think that there is something to say about, going forward. The food industry is a major industry, and the food system and agriculture is like big. So you ask yourself actually why business schools do not spend more attention to that, especially given the sustainability issues. So I think that maybe there is also a push to put together to increase the number of faculty lines and overall activities of business schools in this space, regardless if they're going to have a specific group for that or not.
Can I give you the phone number for our dean?
Oh, sure, no problem. I'm happy to.
We don't have a dean yet.
Oh, that's right. Yeah, sorry.
No, the initiative that we put in place is currently more of a research initiative, but I'm hoping to translate that to more lines, right? I mean, actually, MIT also has a food initiative at the MIT level. So I think already at MIT, the food and water is recognized as a major area of focus. But that said, it's more of, I don't think that they now have invested. It's more leveraging existing resources to focus them on a space of research rather than say, hey, we need to invest in we need to increase the number of faculty that do research on this by factor of 2, right? I think that might be the next level. And I think it will have to be driven by, at least partially by business schools. It's kind of, now come to think about it, it's kind of odd. Like, why would you skip one of the major industries? So,
Well, another thing too about the land grants is there's usually an extension component. Assignment. So, we have our research, service, teaching, et cetera, but extension is heavily emphasized in these land grants. And being here in a business.
What do you mean by extension? Sorry for being
usually working with
the terminology.
Extension has to deal with like working with farmers or working with a community in some way, much in the same sense that, in a business.
I'm happy to do that without extensions, like just do it because it's exciting research.
Yeah, that's, you can get data from the, from the community.
But that's
also,
how you understand what the problem are, right? Like problems are like you do not understand the problem, the problems by talking to policymakers. I can tell you that.
Yeah,
So it's like,
100%. Yeah, and
you have to speak with the farmer to understand how they think about the problem in order to
Mhm.
actually understand what the problem is. So.
oh yeah. One project I'm working on, kind of in the background, is looking at farmers market profitability. And I mean, just talking with a market manager opened my eyes to the way that they think versus what the literature says, in a lot of ways, or what policies can kind of allude.
Models are often things that academics write to themselves to entertain themselves.
Yeah.
It's not necessarily feed the reality. So.
Yeah. Well, it's been eye-opening, and I love being in the business school for that. I came from Penn State, so it was land grant, and being able to kind of scratch the itch of the industry side of things has been able to expand
and I saw that you have courses about. So what kind of courses do you have? I'm actually curious. What are you teaching about this?
For here at ASU.
Yeah, I'm just. My understanding is that you teach courses on food, right? On the food system,
food policy.
Right? And I saw what you teach. So it's the names of the courses suggested that it has to do something with food and agriculture. So
yeah, food and agribusiness policy, and it's just funny that my lecture yesterday was on food safety. So I polished up for no purposeful reason other than it was part of my syllabus.
So if you don't mind, I'm actually about to design a two-day elective course to our executive MBAs about food, and I'm happy to. I mean, if you are willing to share things that you have, and I'm happy to share everything that I would develop, and
Sure.
maybe start even just sharing material on that, if that's okay with you. So I would like.
Yeah, I'll send my syllabus, and then if you see something you like, I can show you.
Yeah, I would be actually. Just even sources of readings and cases and stuff. I don't know if you I'm assuming that you teach also based on some cases, right? So
for the advertising class, but for food policy, mostly a lot of I guess case studies in the sense of it's policy briefs. So yeah, there are case studies. Not.
So whatever you can share, I'm actually happy to, and I'm happy to share everything that I will develop ultimately. So
great.
That could be one other dimension of. Well, actually, among our students, there is actually an immense and increasing interest in food tech. Immense, like the club of the food tech club is 200 people, 250 people across all MIT. So it's actually my plan is to develop in the next couple of years at least one course for the MBA population, because I think that's the way when you win the dean's attention by showing, hey, I have 150 students in my class. That's another line, man.
Yeah.
Give us the line. So that's how it works. So that's the currency in at least in our business school.
Okay.
Bring the students. They're gonna pay you. So they're gonna give you a line. So.
So Retsef, nice to meet you. I'm Elliot Rabinovich.
Hi.
You mentioned food technology. What are some of that's something I'm interested in. What are some of the
I think it's anything from green agriculture to precision agriculture to packaging to. It's very broad. I think they're interested in many things. Food waste is definitely something that is leveraging the food waste to create businesses. Our students are very interested. Many of them are interested in sustainability and not for profit. So, but also. I have a student that sort of talked to me about a new way to grow cotton in a more efficient way in India. It's like it's pretty broad. So I think it's a range of technologies from urban agriculture, different things. So it's broadly defined when I say food tech, if that makes sense.
Right. Okay.
Yeah, there was actually a fellow on the seminar earlier. He's dropped off now, but he's on our campus that works specifically. I think he's an engineer by trade, but he works specifically on vertical agriculture. Within our field, we tend to lump greenhouse and vertical and everything together in a controlled environment. And in my mind, that's something that we don't know enough about, and that's coming. If you look at private capital markets, there's so much money flooding into that thing. It solves, well, it doesn't solve, but it helps with, water problems, waste problems, emission problems, food safety problems. It resolves a lot of these externalities we've been fighting with for years.
Yeah, I mean, recently I also saw some efforts around, how do you actually provide energy to farmers that is much more efficient, like reduce energy consumption, put solar panels in farms, things like that. I mean, it's really a big space.
Right. All right, Retsef, I got to drop off. Thank you very
same
much.
here. I'm sorry, I have another meeting, but it was a pleasure. So Lauren, I will see you a contact person for further collaboration. I mean, I'm happy to explore even submitting grants together. We have a large group of faculty. You have a group of faculty. I think I'm very open to explore collaborations with you guys.
Yeah, and actually I'm working on developing some.
So one of the, just to make a point, one of the things that we've worked with is actually an organization, an industry organization on the lettuce, the green leaf farmers that organize that in the context of the contamination, and they actually are in Arizona.
Yeah.
And we were quite advanced with them, but then funding was an issue. But we can potentially discuss if that's something interesting to you, the green leaf supply chain, especially that a lot of it is in Arizona in the US.
Is that the LGMA, the Leafy Greens Marketing Association? Sounds like it.
I'm now blanking on the name, but it doesn't ring a bell that was the name. But I'm gonna check the exact name. I don't want to just misspeak, and I'm gonna send you all the contact people. We haven't interacted with them for several months now. But if you think that there is, I mean, I think it's gonna be more powerful even to have people on the ground also close to them. It's gonna make things easier. And I don't know if you will have ideas to get funding to something like that, because I think it could be something also at the national level of, take the green leaf supply chain as a something that has deficiencies that repeatedly create problems. And can we create a better system to address those issues?
Yeah.
If that's something interesting to you, then I'm happy to sort of brainstorm whether we can put together maybe a collaborative effort that is, sometimes it's easier to scale the effort to get funding.
Yeah, so. And for something that's based in Arizona, we have specialty crop block grant programs and things like that.
Oh, okay, so maybe the state can actually fund, right? So that would be great. So,
I mean, just logistically.
So I'm happy to send you. We have a document of what we wanted to do. And I'm happy to share with you and see if it's something interesting to you to collaborate on. Then we're happy to explore that.
Yeah, absolutely. Yeah, I think we have a lot of common things, and maybe reciprocity in the fact of what we
we listen. I've never written a single author paper in my life, so I'm proud of it. So it's like I'm a big believer in collaborations. Like big problems are solved with multiple teams. You don't solve them with one team. So.
Well, and you were talking about NLP and some of the matching methods that you use for your data sets, and that's a whole other thing I'm looking into. So
if you have things that you want to brainstorm on, I'm happy to sort of see if we can help. In fact,
I don't know if do you know Julia Lane? I don't think you can see my book here, but she just sent me a book on rich context. Using some kind of like NLP to match different links.
Any problem that you have and you want to brainstorm, just send me an email. We're happy to talk about. So.
All right, awesome. Yeah, I could definitely use your insight there. But great chatting and
pleasure to meet all of you. Take care, stay safe, and enjoy the weekend. Hopefully the vaccines are coming along in Arizona as well.
Yeah, definitely.
Thank you very much.
Take care. Bye.
Thank you. Bye.